the last little thing I wanted to review in this first section of the book is what about equations that don't have answers or that have more than one answer, which is a possibility even for simple equations such as this. And what does that look like? And I also wanted to review how do we write our answer and what are some of the terms and things we refer to these as, because they are relevant later. But anyways, let's look at an example. So let's start by solving the left-hand equation on the packet, this is on the second page of that handout, at the top from what we were just working on here. So I might skip around a little bit through the packet. I don't know if you were wondering about this, and always feel free to solve all the other ones too if you want to practice more. But you should get more practice when you go work on the homework for each of those sections. It should always be very similar to the lecture, and it should just test you on your ability to do these sorts of questions. But anyways, let's go ahead and work on this one. So in this equation, well, we could simplify both sides. So we could simplify the left-hand side, which would be by distributive property. And also remember about the distributive property is that when there is a negative or minus sign, whatever, out front, that negative applies to the 3, which implies that this number is negative. When you multiply the 3 out, the negative will need to distribute with it, because it's not like negative 3. If a negative 3 is applied to the 3, that implies it's applied to the whole thing, not just the first term. So it'd be negative 3 times x, which is negative 3x, and negative 3 times negative 9, which is positive 27. Additionally, we can combine terms on the right-hand side because 4x and 7x are both x's, and that would give us negative 3x. But we can't add the 27 because it is not alike. And then notice in this case, what we're left with is negative 3x plus 27 is equal to negative 3x plus 27. And if we just stop for a second and really look at this equation, we can tell that, well, of course this is true. Negative 3x plus 28, it's the same thing on both sides. It's a little bit unusual when comparing to the other equations we've been dealing with. And so this could get us stuck for a minute. It's like, well, this equation is a little bit strange. But this is an equation that is obviously true. And if we continue working on our algebra process, well, what we were taught to do, based on the step-by-step guide is, well, we want to put all the variable terms on one side. So, I could add 3x to both sides, but notice since it's the same thing on both sides, if I do that, actually the 3x plus 3x will actually cancel on both sides. And that will leave me with 27 is equal to 27. And so the variable terms are completely gone. It's a little bit weird. And this is kind of an indication for one of these special cases of these equations, which just means it's going to have a slightly different answer. It means it's either going to not have an answer or it's going to have infinite answers. And how do you discern which is which? But really, you could go even further by putting all the numbers on one side, because I have 27 on both sides. If I was to subtract 27 from both sides, what I'd end up with 0 is equal to 0. So and from here, you can't really simplify this equation any further. It's about that's as far as we can take it. But really, we could have identified what this equation is, what special case it is from up here when we recognize, okay, yes, this is most definitely true. And 27 is equal to 27, right? We know that's true always. And 0 is equal to 0. Yeah, that's true always. So, and same with this equation. As soon as you recognize that, yes, this is true always, what that means is an equation that actually has infinite solutions, meaning it does not matter what x is, all values of x are correct solutions. And that, since again we were using the properties of equality, that implies that the original equation also has the same thing, because right when I did the first step, all I did was simplify, and that first equation is really the same thing. So, and really, basically what this means is I could plug in any number for x and it will work. Because say if x is 10, well, or x is 50, it's going to work. So let's just pick a random number at example. Let's say negative 3. And we were to plug that into our original equation. I would have negative 3 times negative 3 minus 9, and that was just a totally random choice to sort of demonstrate what I'm saying here. And remember, when you're plugging in negatives into the solution for your equation, you want to make sure to use parentheses when you substitute them for x, so that you're multiplying and not subtracting on accident. But basically what I would be left with here is negative 3 times negative 12, which is 36. And on the right-hand side, I have negative 4. I have 4 times negative 3, which is negative 12 plus 27. And negative 7 times negative 3 is positive 21. And that would leave me with negative 12 plus 27 is 15. 15 plus 21 is 36. And so what I can tell is that, okay, negative 3 was a solution to the equation. But that was my whole point, going back to recognizing this is an equation that has infinite solutions because it's always true. And when I simplify it, I get something, this statement is always true. That means this is always true regardless of what x is, and same with up here. And now the question is, how do I write my answer? And a lot of students are taught to write infinite solutions, which is not wrong, but it's a little bit ambiguous because technically any value of x is our answer. And basically there is an infinite number of solutions, but this is not very specific in terms of, well, what is the nature of those solutions. So another way that you could write it is x is all real numbers, which just means that x could be any number, or often we write the symbol, like we write it symbolically like this. X is an element of the set R, which just stands for every number. It includes decimals, fractions, whole numbers, negatives, and irrational numbers, rational numbers. We'll review that, what all that means later. But this would be more correct. Or another way you might remember, we write it as minus infinity, comma, infinity. We'll review what we call interval notation very, very soon in our Monday's lecture, and also a little bit when we have class time on Wednesday. But anyways, if you're wondering, how do I write my answer? Well, I don't care, as long as you indicate that all the answers work. So any of these ways of writing it are fine. But typically when we have multiple solutions or lots of answers, we write, typically the more correct way is to use interval notation or mathematical set notation. And not everybody's too familiar, or, these are the things that if you don't remember or don't use these symbols, you tend to forget them. So I wouldn't be surprised if a lot of you didn't really remember all of those. Again, that's the point of the video. Anyways, doing one more, and that's the case when there's no solutions, and you can guess because there's two different examples on the packet here. This one was infinite solutions. This one's probably going to have no solutions. But in the same way, if we start simplifying the equation, basically, you're not necessarily going to recognize it right away, but as you're solving, there's something that happens that triggers this recognition. And in this case, it's if you have the same thing on both sides when you're simplifying, that indicates infinite solutions. Now, if you come up with something when you have different things on both sides and it's clearly not correct, whereas in this case, it's clearly correct. When it's clearly not correct, that's when you know there is no solution. But let's simplify. So on the left-hand side, I have 5 plus x minus 7, and the minus 7 would distribute just like in the last case. So I'd have minus 7x minus 7. And that's equal to, this is looks a little weird on the right-hand side, but even if the number comes second, it would still distribute, we would still use the distributive property in the same way, which would leave us with negative 6x minus 12. And so I would combine anything that I can. On the left-hand side, I have 5 minus 7, which is negative 2. And I have x minus 7x, which are also like terms, which would be minus 6x. And on the right-hand side, I cannot combine those. And now noticing in a very similar way, notice that the variable terms end up being exactly the same as it was in the last case. And if I were to add 6x to both sides, or you might call this the cancellation property of equation, if you have the same thing on both sides, you can cancel them out. Now you got to be careful with more difficult equations in using that logic, but in a basic equation, if it's the same thing on both sides, you can just nix it because you could add 6x to both sides, which would be 0, and both sides would cancel. But basically what that would leave me with in this case is negative 2 is equal to negative 12. And that's clearly not true, right? If we're looking at that equation, it's clearly nonsense, or it's what's called a false equation. Or you could even add 2 to both sides and give us with 0 is equal to -10, or add 10 to both sides and get 10 is equal to 0. I mean, you can do whatever you want to make this equation look prettier, but no matter what you do, you're going to end up with something nonsense, clearly false. Or sometimes people call this a contradiction. And again, what does that mean? Well, since this is false, what that implies is that this is not true, and this is not true, and also this is not true. It means the entire equation is nonsense, or there is no solution. There is no way of solving this equation because it's impossible. It results in a false statement. And so, how you write your answer is a lot of times we're taught to write no solution, which is totally fine. It's correct because there is no answer. Or using a set symbol, you could say X is an element of the empty set. Or sometimes it's written like this in a set notation. Basically, there is no answer. You don't write X is equal to what's the null set, or it's the 0 with a line through it. And remember, this is not 0. This is another mistake I've seen some students write, is some students will write 0 using the slash, but the 0 with a slash through it is not the same as 0. It means literally no answer, no solution. And it's different from this because X equals 0. This is sometimes the answer to an equation. 0 is a number and it is an acceptable answer. But not having an answer is different. And that's what we just say. Basically, there is no answer. Or you could just write the null set by itself. Anyways, there's various ways you can write this. But this would be kind of the most correct symbol to use for no solutions. And this is, I think, how it appears in your online homework. And also, I wanted to mention one last thing that I forgot about, is that an equation that's always true, like this one, is sometimes called an identity, a mathematical identity. So going back to the left-hand side, we would refer to all of this, like even the original equation, as an identity, which just means that it's always true. And basically, it's something which implies that it's a mathematical equivalency statement. And sometimes, like for example, if you've ever had trigonometry, or if you're going to take pre-calc next semester, you'll deal with what are called trigonometric identities, which, for example, you have sine squared theta plus cosine squared theta equal 1. And the fact that they call it an identity, that's exactly what this means. That this is an equation which is true no matter what you plug in for the variable, which in this case would be theta. Now don't worry about that for right now. Anyways, it's an important terminology thing in math. And another identity is like x plus x is equal to 2x. It's kind of like a statement that, okay, yeah, these two things are the same, right? Because if I have 1x plus one more x, that makes 2 of the same thing, right? If I have 4 plus 4, it's twice 4, 8. Or if you have another common identity is x times x is x squared, it's easy to mix up those two identities. But it's just like a mathematical statement. And we often use identities in textbooks to say, okay, this is just a true statement. Anyways, this video is getting too long, sorry. Let's wrap it up.